Hello everyone. The course title is Introduction to VLSI. VLSI stands for Very Large Scale Integration. What is the meaning of very large scale integration? Very large emphasizes that there is something that is huge in number. What are they? They are transistors. How many number of transistors? In fact, there are millions and billions. Now the question is, what is the area in which these transistors are integrated? It is in few centimeter square area. It is really astonishing. In fact, the invention of transistor has revolutionized the way human beings live today. It has affected all walks of human life. Now what is the meaning of integration? All the semiconductor devices like transistors, diodes, etc. and the circuit elements like resistors, capacitors, etc. of a circuit, all of them are fabricated on a single piece of silicon, including the interconnections. If you take a circuit on a breadboard, you have discrete components made of different materials and they are connected with wires. In case of integrated circuit, all the components and the interconnections are made on a single piece of silicon. That is the meaning of integration. Let me repeat one more time. In case of an integrated circuit, all the components and the interconnections are made on a single piece of silicon. Well, VLSI comes with extensions. The extensions are VLSI design and technology. Well, if you are having an integrated circuit or simply a chip in your hand, it is the result of both design as well as technology. For example, VLSI design is like a recipe of the dish, while VLSI technology is like the actual cooking of the dish. Therefore, if you were to bring out an IC, first you have to work with its specifications like the functionality of the chip, for example, an adder circuit. Then constraints like what is the size of the chip, what is the area it should occupy, what is the performance, power dissipation, etc. This is either paperwork if you have few number of transistors in that particular circuit, else if the number of transistors are large or circuit is large, then you have to use some numerical softwares. Once the design part is finished, you have to actually manufacture the chip, which is called as fabrication. The manufacturing of chip is called as fabrication. The rules that govern the fabrication process are called as VLSI technology. For example, you are designing a MOSFET circuit. You have a metal oxide structure. The dimensions of these layers are also very important in this course. For example, what is the thickness of oxide? Even though this parameter is more to do with VLSI technology, still VLSI designer should know the importance of this parameter. Oxide thickness and area. Also, what is the distance between the source and drain regions? In fact, this is the length of the channel. What is the width of the channel? These dimensions are very important for a VLSI design engineer. Assume one of your designs is yielding very good results with 1 cm thick oxide. But such structure cannot be fabricated for the reason growing 1 cm oxide is not possible. Design as principles, also technology as principles. Both design and technology will go hand in hand. This course emphasizes on VLSI design. If you are to be a good VLSI designer, you also should have good knowledge of VLSI technology. In this course, we will not be dealing with VLSI technology at length, but our emphasis is more on VLSI design. Of course, we will also touch upon some aspects of technology as well. Also, you must be well versed with analog as well as digital design. When you say analog design, you will design circuits with MOSFETs, bipolar junction transistors, etc. When you say digital design, you will design at logic level. VLSI design, you can think it as an extension of both of these designs. Now a question. What is there inside of a logic gate? The answer is transistors. In a VLSI based circuit, MOSFET is a predominant device. Again, it is not discrete N-channel MOSFET or P-channel MOSFET, but complementary NMOS and PMOS, which is called as CMOS circuit. The advantage is less static power dissipation in case of CMOS circuits, details of which we will see in the later classes. Therefore, the course title is CMOS VLSI Design, and this is one of the important courses for an ECE student. So the apt title for this course is CMOS VLSI Design. Now what is the objective of VLSI design? The objective of VLSI design is to improve packing density. That is, to put more number of transistors or circuits in a given area. For example, few centimeter square area. In few centimeter square area, you are going to pack like millions and billions of transistors. Also, the other objective of VLSI design is to increase the performance, that is, increasing the speed of the ICs. At the same time, we need to reduce the cost of the chips and also reduce the power dissipation. The objective of VLSI design is to improve packing density of the transistors, increase the performance, at the same time reduce cost and power dissipation. So a good VLSI design has more number of transistors in a small area with increased speed, at the same time low cost and low power dissipation in the circuit or the chip. In summary, we have seen the difference between VLSI design and VLSI technology. We will be looking at the CMOS VLSI design in this course. Also, we have seen the objective of VLSI design. The few softwares and the hardware part that will be required for this course are LT-SPICE for circuit simulations. We will use Logisim for digital simulations. The electric software, in fact the VLSI electric software for laying out the transistors, and we will be using Verilog or VHDL. Also we will be using FPGA boards. So the outline of the course briefly is, we will discuss about design methodology, design domains, VLSI design flow, design styles, etc. And we will deal with the fabrication of the MOS devices. We also will study about MOS transistors and inverters. So the CMOS inverter, the various circuits like resistive load inverter, enhancement type NMOS load inverter, depletion type NMOS load inverter, etc. And we will look at the CMOS, digital CMOS logic design. And we also will look at the digital system synthesis and verification. This is the broad outline of this particular course. And the textbooks are CMOS Digital Integrated Circuits by Sung Mo Kong and Yusuf Leblibichi, and CMOS VLSI Design, a Circuits and Systems Perspective by Neil West and David Harris, VLSI Design by Devaprasad Das, and Samir Palnitkar, Verilog HDL. So these are some of the textbooks I would be referring to. Hope you will try to understand the essence of this CMOS VLSI design in the coming lectures. If you want to give feedback on these lectures, you can give your feedback at ebpaul.lectures@gmail.com. Thank you.